Section 23.9, the Dieckmann condensation. The Dieckmann condensation is the intramolecular Claisen condensation. It's similar to what we saw with the intramolecular aldol. It's useful to make 5 and 6 membered rings. And in the middle of the 20th century, when folks were trying to make all of the androgens, the steroids, these are all fused 6 and 5 membered ring systems, so this was a very powerful methodology. So let's take a quick look at it. There's 2, 3, 4, 5. So we can make 5 and 6 membered rings. So we have 1, 2, 3, 4, 5, 6. A 1,6 diester. Then we can do a Dieckmann condensation. And we will produce a product with a 5-membered ring. Now I'm trying to orient you so you can see the atoms. There's atom 1. This will be 5, and so 5 will still have the ester on it. And so we can effectively make a 5-membered ring. Now remember the driving force for the Claisen condensation? It's the same thing here. It is the removal of that proton that's now very acidic because it's alpha to 2 carbonyls that drives this reaction. So typically you'll see it 1 base and then 2 an acidic workup to find that. But remember, that's going to enolize, and you'll have the enol form as well. So we can make 5-membered rings. We can also make 6-membered rings, but we're going to need to have another carbon in our ester. So I'm going to draw this one. 3, 4, 5, 6, and now I'm going to draw it a little strange here. So we need now a 1,7 diester to make the 6-membered ring. So watch now. 1, 2, 3, 4, 5, and 6. It's symmetrical, so it doesn't matter if 2 attacks 7 or if 6 attacks 1. And again, with first ethoxide and then an aqueous acidic workup, we will make a 6-membered ring. And again, 1, 2, 3, 4, 5, 6 atoms there to make the 6-membered ring. So that is the Dieckmann condensation. This is very powerful and useful synthetic methodology. And one of the key elements then is to use substituted systems in this chemistry. So you can have substituents around the ring in different places. All right, so take a look at the specific problems in the end of the chapter and in the workbook for the Dieckmann condensation 23.9.